Hi everybody and welcome. Today we're going to be talking about polynomials. So your goal after watching this video should be able to identify a polynomial, classify a polynomial, and also identify the degree of a polynomial. So today, not a big calculation day, more of a definition day. So kind of starting off this unit, I want to make sure we have a good understanding of what we're talking about and how it applies and kind of some of those more vocab specific examples. So as always, starting off with a real world application. So the cool thing about polynomials is they're honestly pretty versatile functions. So something like a roller coaster, very complicated, but with roller coasters, they're smooth, they're connected, they're continuous. So we can actually model these with polynomials. So polynomials have some properties basically that allow them to be used in many different ways, but in a way like this roller coaster, again, where it's that smooth, continuous line. A lot of examples. So if we're looking at, linear lines, those would be examples of polynomials as well. Seeing quadratic, cubic functions, again, examples of polynomials. Basically, as long as you have a shape that you can trace without having to take your pencil off of the paper, likely it is a polynomial. So a lot of different applications here, pretty versatile. And with what we're dealing with this year, it's going to be kind of a good way to anchor the understanding of the next unit of functions that we're talking about. So to start off, we'll do some definitions. So first, let's define polynomial. So even though polynomial means many, it doesn't actually need to have many terms. It can actually even be just one term. So it's kind of hard to define, but I think a good way to remember it is there's some rules that we'll say about polynomials. So some rules for polynomials are they can have constants, variables, exponents, but some things that they can't have are division via variable, nor fractional exponents. And fractional exponents are just a fancy way to say no square roots. So things that can be polynomials would be like 7 over 9 times x. Again, there's no x in the denominator, so that's okay. We could have like the square root of 2 times x. Again, x is not inside of the radical, so that's okay. We could have 5, doesn't even need to be a variable, and something as simple as like 3x, polynomial. Any of these four things work individually. They are each polynomials. Things that don't work though. So again, can't have negative exponents. So we can't have y to the negative 2 power. That does not work. That's not a polynomial. X in a radical. That would also not work, so like the square root of x. So you can also write it as x over 1/2. Again, those two things are the same, and neither of them are polynomials. And then finally, if you have something like 2 divided by x, again, does not work, not a polynomial. So all four of these things are not polynomials on the right side, but the four on the left are. So some examples and some non-examples. And with a little bit of practice, we'll see that the common ones where they'll try to trick you and say, is this a polynomial? And you'll just have to identify some of those factors. So again, the big ones to remember though, negative exponents, fractional exponents, or division by a variable. All right. A second definition today is the degree of a polynomial. And this is defined as the largest exponent on the variable. So if you have a polynomial expression, something like x to the 3rd power, the only exponent and the largest exponent is 3, so that's the degree. The degree is 3. So we're not saying that x cubed equals 3, and we're not going to take the cube root of 3. We're saying that 3 is the degree of this polynomial. Another one, y squared times x squared. Commonly you might think, oh, the biggest number I see here is 2, but 2 plus 2 equals 4 will get you the degree of the polynomial. And then finally, another common trick example, if you have like x times y squared, again, you're like, oh, I just see the 2, but there is an invisible 1 hiding here at this x. So it's actually 1 plus 2, or 3 is the degree of the polynomial. So a couple things to watch out for there, but on the whole, if we're being careful as we're going through, we should be in good shape to be able to successfully calculate those degrees. All right, so a few example problems before we go on, and some final pieces of terminology. So with polynomials, we can actually have, so I'm going to change this here to define monomial. It means that there is just one term, so something like 3x, that's a monomial. Or you could have something like 3x, y, z. Again, it's one term, it's not 3 plus x plus y plus z, it's just altogether 3x, y, z as one term. Binomial is two terms. So that would be like if we had, 2x plus 1. Again, there are two separate terms. There's a 2x and there's a 1. They're separate. That's two terms. And then trinomial, you can probably guess 3 terms. So 3 separate things we can add, subtract together. So maybe it's 4 plus 2x plus 3x squared. So those would be some examples. All right, so on the bottom, we want to name what these things are. So here it's 2 times y. That's actually one term. So that is a monomial, or 1. Binomial is 2 terms. And then finally here we have 3 terms. So that is going to be our trinomial. All right, so some examples. Again, in practice, those bottom 3 might be something that you might see on like a worksheet, mastery ticket, assessment, something like that. And then finally, a couple last examples here that will help us go through. So this question is asking you, is it a polynomial? If it is, what type is it? And furthermore, what is the degree? So first off, we see a radical sign here, so we see that this one is actually not a polynomial. So we don't have to do anything more beyond that. So be careful going through the rest of these. Make sure that, again, first they are polynomials. Next one here, we don't see any of the things we're not allowed to do. So no negative exponents, no fractional exponents. We're not dividing by any variables for number 2, so this looks okay. There are 3 terms, so we can call that a trinomial. And then finally, the largest exponent is x to the 5th power. So it is a 5th degree polynomial. Again, we're not going to add the 2 together, so it's not like, oh, x to the 5th power and then minus 3x. We're not going to do the 5 plus 1. It's just for the biggest term, what is its degree? So the biggest term is 4x to the 5th power. The degree of that one is 5. So that's why it's a 5th degree polynomial. So go through these ones, finish up the last 4 here, define what terms they are. If it's something like this last one here, where you have 4 separate terms, that's not a monomial, it's not a binomial, it's not a trinomial, so the only thing that you're left with is you can just label it as a polynomial, and that is okay to have as your answer there. And again, don't forget those degrees. Be careful calculating them, make sure that you're not forgetting. Like on this question here, there is an invisible 1 by the x, and there is an invisible 1 by the z. So a few things to take note of there before you go through and finish. Awesome. Well, thanks for tuning in, everybody. I'll see you all in class soon. As always, any questions, definitely reach out.